Professor Chad Topaz is a president of mathematics. He's an applied mathematician and a data scientist at Williams College. His research is on complex and nonlinear systems, and that's been supported continuously by the NSF since 2006. His other stream of research applies quantitative tools to expose and remedy social injustice, and is based out of the Institute for the Quantitative Study of Inclusion, Diversity, and Equity, which he founded. His teaching career stands on an intense interest in human learning, on scrupulous attention to learners' needs and challenges, and on the belief that education is both an art and a science. An avid follower of scholarly research in education studies and educational psychology, he has won a number of teaching awards. He is interested in department and institution level perspective. He enjoys serving as a program design consultant and external department reviewer. One of his greatest fulfillments has been the melding of his teaching and research lives in the sphere of undergraduate research. He has advised over 100 summer research, capstone, independent study, and honors experiences, with over 50% of these for women and members of other underrepresented groups. And with that, I want to thank you very much, Chad, for joining us today, and I'll turn it over to you.
Okay, thanks, Abby, and thanks everyone for being here. It's like, it feels like an honor to me to have the chance to spend an hour with you all thinking about maybe challenges of the upcoming fall. Before I get into the meat of this talk, I just want to go through a few preliminaries that frame how I am approaching this. And maybe the first thing is that I'll give you a glimpse of what it's like when I give research talks. When I give research talks, the audience usually looks something like this. Everyone's like, yes, Chad, that was a very nice bifurcation you've just described to us, or something. And it's, you know, people just say, okay. On the other hand, when I give teaching talks, often the feeling in the audience can get a little bit more like this. There's just a lot more feeling in my experience when we talk about teaching, because it's something that is really very personal to us, I think. And so with that said, you know, I always like to make clear why I'm here. And I'm not here because I want to tell you what I think you should do, or I want to tell you what I think of what your college or university is doing, or any of those things. I just want to share my own current thinking about how I approach teaching online, and about how I'm thinking about this fall with the Discrete Mathematics course that I will be teaching. Also, you know, we're at a really strange and kind of unsettling time in the world right now. And if you were to ask me, like, what are my priorities, Chad? Like, what's on your mind? I'd be like, well, number one, like, I'm thinking about stopping police killing of Black people. Like, I'd like to please stop the spread of fascism globally. I'd like to advocate for public health for all people. I want to support my students. I'd like to maintain my family's well-being and tend to my mental health and my students' mental health, and, you know, all these sorts of things. And then in no particular order, somewhere further down the list, there's like, I want to catch up on season 5 of Queer Eye, and like also teaching math, right? And that's not to devalue at all what we're doing professionally, but it's to say that the world is often a hard place, but it's especially hard right now. And the way I am approaching my fall term is to just try to create a little bit of mental space and say this endeavor of me teaching my students is actually not the most important thing in the world. It's something I want to do well, but it's not the most important thing in the world. Also, let's talk about the online aspect of teaching. So we can think about classes that are in person and online, and we can think about classes that are awesome and classes that are disastrous. And we can ask if these various combinations exist, and the answer is that they all can exist. So to me, when we say the phrase online course, oftentimes people fixate first on the online part of it. And my own approach is to think of the online part as sort of secondary business, and to just first and foremost think about it being a course, right? If I do a good job designing a course, then really I just need to find a way to be able to translate it into an online environment. And that, you know, for everyone in this webinar, it's going to be different for us because we're all at different institutions. We all have different technological affordances. Our students have different technological affordances in situations and all of these things. So I might not be able to speak to all of the technical constraints that we're all under, but I'm going to try to focus a little bit on just good course design and how I have tried to do my course design and translate it online. And so that's what I'm going to do. I'm going to talk first about some ideas from learning science that have influenced me. And then I'm just going to give you an overview of different features of my online discrete math course that I'll be teaching at Williams College this fall. So to start off this learning science discussion, I'd like to tell you about the pedagogical model that I follow. And you know, the learning sciences literature is really big and really rich and has a lot to say. And probably if we are full-time mathematics instructors, we may not have the time to, you know, read and parse all of that research. So for me, having a few sort of touchstones in that literature is really helpful. And this is a pedagogical model that I really like. So this is from a book called How People Learn. A number of you may well know this book. The first edition of this book came out around the year 2000, and it was put out by the National Academy of Sciences. And it was sort of a review of everything that at the time was known about human learning, kind of a big review paper from the standpoints of neuroscience and educational psychology and education studies and sociology, and really any discipline that has something to say about how people learn. And my favorite chapter of this book is, I think it's chapter 6. It's called The Design of Learning Environments. This book, by the way, is completely freely downloadable. You can get this for free as a PDF from the National Academies. And so what this chapter says is that the consensus of the literature is that successful learning environments all have 4 things in common. Like the first is that they're knowledge-centered. And this is the thing that we're traditionally really good at doing in the mathematical sciences, right? It's like putting content on the stuff that we want our students to know and be able to do. But successful learning environments also need to be learner-centered. And that means paying attention to learners as individuals, recognizing that all learners come into our classrooms with different goals, different life experiences, different I don't know, different course schedules, different all sorts of things that lead to them having their own unique experience in the class. And so this is sort of like saying that it's important not to adopt a one-size-fits-all approach. Assessment-centeredness has to do with giving students frequent opportunities for ongoing formative assessment so that they are getting feedback on how their learning is going, and so that I, the instructor, am getting feedback on how their learning is going. And then all of these 3 things are hopefully taking place under the umbrella of community-centeredness, and that has a lot of aspects to it, including, you know, the connections between what a student learns in your classroom and other communities in their lives that are important to them. But another important aspect of community-centeredness has to do with sort of like building a learning community within the course and perhaps fostering peer collaboration and that sort of thing. So whenever I design a course, all I do is ask myself if I have found mechanisms to do these 4 things. And when I show you my discrete math course a little bit down the road, I will come back to these 4 things and try to show you a little checklist of how the course activities map to these. So now one of these 4 circles here was knowledge-centeredness. So let's say a few more words about knowledge. Some of you might have heard of Bloom's taxonomy. This is sort of like a classic thing from the learning sciences about how to think about different kinds of learning goals. Maybe we want students to remember things or understand things, apply, analyze, evaluate, and create. And Bloom, in his original work, like visualized this as this sort of pyramidal hierarchy. there is a revision of Bloom's taxonomy that I really like by Anderson and Krathwohl. And in this model, any student learning goal can be put in the form of a sentence that says students will be able to verb noun, where verb is something called a cognitive process, and noun is something called a knowledge type. And so I want you to imagine this matrix. Well, you don't have to imagine it because I'm showing it to you. Here's this matrix that represents Bloom's taxonomy, and these verbs going across the top, these are the verbs from Bloom's original taxonomy. So that you remember the understand, the apply, and so on. And this is called like the cognitive process dimension. But now we've added this other dimension, which is the knowledge dimension. And it's just saying there's different kinds of knowledge. There's knowledge of facts. That's like, what year did World War II start? There's knowledge of concepts, which has to do with the relationships between things and ideas. There's knowledge of procedures, that's how to do stuff. And there's metacognitive knowledge, which is really complicated but really important. And one dimension of it for learners has to do with thinking about their own learning process. And so, why do I introduce all of this? It's just to say that, you know, these can all be important things. And whenever I think about learning goals for my students, I think about where in this matrix they might fall. And just to give you an example, since I'm teaching discrete math, if I would like students to be able to construct the contrapositive of a given conditional statement, well, to me, that's like, they're going to think like, oh, if P then Q, and like to make the contrapositive, I should like switch those things around and negate them. So they're like basically applying a procedure to a statement that I've given them, right? This is just like one little example. And there's no, to me, there's no like right way about like what to fill in this matrix. There's no right answer, but for me, it has been a helpful reflective tool as I think about what I would like to ask my students to do. I just sort of diagnose under the specific thing I want them to do, what kind of broad sorts of learning goals are going on. Okay, let me move on. And try to say a thing or two about learning and enjoyment, because learning should be fun, right? And so there's this classic paper I want to introduce you to if you don't know it. This is from Richard Clark in 1982. And the name of this paper was Antagonism Between Achievement and Enjoyment in ATI Studies, which is a particular kind of sort of psychological design for an experiment. And the key quotation from this paper is, there's evidence that negative correlations between student achievement and their enjoyment of instructional methods exist under certain circumstances. Students often reported enjoying the method from which they learned the least. Okay, so if you don't believe educational psychology from 1982, I can give you a much more recent example. This is a paper from PNAS from last year. And the titles of these papers are also great. This one was called Measuring Actual Learning versus Feeling of Learning in Response to Being Actively Engaged in the Classroom. And the study that was done here was in a physics class. And so I'm showing you results for parts of the class that had to do with learning statics. And there were different groups of students that received sort of different instructional models. And one was a passive, sort of very lecture-based model, and one was a more active learning model. And what you're seeing to the left of the dotted line here is just some like normalized result of how these two different groups did on some learning assessment in this unit. And so what you're supposed to take away from this is that the students who had the active learning modality did a bit better. On the other hand, to the right of the dotted line, you see how the groups of students felt about things like, I enjoyed the lecture, I feel like I learned a great deal, the instructor was effective at teaching, I wish all my physics courses were taught this way. And you can see that everyone liked the active learning model less, right? The students expressed less satisfaction, even though according to the instrument used, their learning outcome was better, right? So it's just to say that I don't want people to feel lack of enjoyment, but that for me, when I approach designing a course for my students, I'm not thinking as a primary consideration, like, oh, are they gonna like this or not? And so here's another little table I make for myself. I call this Chad's totally made up matrix of learning and enjoyment. And what I think to myself is, like, for anything that I do, for any instructional component of my class, like, there could be an effect on student learning that's negative. I would definitely like to avoid things that make them learn less. There could be a neutral effect on student learning, like it doesn't really help them, or it could help them learn. And then there's, like, on the perpendicular axis, some effect on their enjoyment. Like, they really hate it, they don't really care so much, or they love it. And so for me, I try to avoid things that hinder their learning. I try to avoid things that they hate, unless I really think it's going to help them learn. And I do think it's okay to judiciously make choices about things that are great for student learning, but students really hate. And then I think about filling in these other boxes as well. Let's talk for a minute about the learning science of goals and motivation. So I think when in our community, when we talk about teaching and learning, I hear we all I think often say a lot of these sorts of statements, right? These are the kinds of things that we say, like, posting the grade distribution for this exam might help motivate lower performing students, or contests and competitions will engage and motivate students, or my students would learn more if they cared less about grades, or the best students are those who just love math, or if I show my students the beauty of a topic, they'll learn it better, or if I show my students the value of a mathematical technique, they'll learn it better. And I don't necessarily think any of these things are false, and I don't necessarily think any of these things are true. I think it's really complicated, and so I would like to delve into
Chad,
that.
I just would like to interrupt, if you don't mind,
Please.
to share a comment that someone made in the chat.
Sure.
Maybe student enjoyment is more important in online or remote context in order to keep up engagement. I don't know if you have any reaction to that.
Sure, that's a great point. I mean, it could be that enjoyment contributes to engagement, but again, I do agree that engagement is important, and in my head, I will keep that front and center, right? There's lots of ways I can make my students engage, and they might not like it, right? Like, they might sometimes prefer to not be engaged. That doesn't mean that that is better for their learning. So, I mean, yes, again, please don't think that I'm anti-enjoyment, like, yay, enjoyment. To me, it's never the primary goal. It's always in service of something. So if enjoyment is going to help them engage, then absolutely. And sorry, because now probably 200 people are hearing my dogs bark in the background. In any case, were there Abby, other comments or questions we should discuss now? No. Okay. So, so this is a little bit about goals and motivation, some things that we say about goals and motivation. So let's dissect this. I want to talk about goal orientation. And when we talk about the goal, the way we approach goals, you might have heard these terms like mastery goals or performance goals. And, like, really crudely put, a mastery goal orientation is something like, I want to learn the material. And a performance goal orientation would be something like, I want to get a good grade, right? And it's not that we have one or the other of these things. We all, as humans, tend to have some level of each of these. And in fact, what I understand from the learning sciences literature says it's actually not that we want students to have one or the other. It's that the best learning outcomes are achieved for students when they have some amount of both of these. Now, besides just having the mastery and performance orientations, for each one of those, there can be an approach or an avoidance. And so just to give you an example, performance avoidance means, like, you want to avoid looking like you don't know what you're doing, okay? Or a mastery approach means you would like to approach understanding of a concept. So really the model looks like something like this. Like, maybe I have I have a low level of performance approach for a learning task and a high level of, mastery avoidance, something like this, okay? goals are even more complicated because what I've shown you here varies from situation to situation. So we often talk about trait goal orientation and state goal orientation. And trait goal orientation is something that like is true about you inherently as a trait of your personality. But for these sorts of learning tasks, they're often state orientations that might vary from class to class or subject to subject or day to day, right? So maybe there's a student who really wants to master their learning in their math class, but actually in their Arabic class, they are like less motivated to try to master the material, something like this, right? So it can be very situation specific. Now, just because there are goals doesn't mean that a student is motivated towards those goals. So here are a couple of models of motivation and how I think about them. So once a student has a goal, there's these three stages of motivation called choice, persistence, and effort. And here I'm calling on a model of Clark and Estes. So the active choice means the decision to pursue a goal, like, hey, I want to learn calculus. Like, I'm going to enroll in this calculus class. Okay, the persistence is like continuing in the face of challenges and distractions. So that could be like, oh, life is really complicated and I have all this other stuff to do, but like, you know, learning calculus matters to me, so I'm going to show up to class. Okay, the mental effort part is a stage beyond persistence. It's not just keeping trying, it's real intellectual investment. And so to draw a distinction between those two things, I could show up to calculus class every day and I would be persisting in attending. But if I'm not actually thinking hard about what's happening and what's being said in class, then I may not be putting in enough mental effort. And sort of in the progression along these sort of stages of motivation, I have these green arrows, okay? And for me, what each of these green arrows represents is something called an expectancy valence decision. And expectancy is the belief that an action will lead to an outcome, and the valence is like, do you care about the outcome? So for example, if you're enrolled in your calculus class and your subconscious mind is trying to decide, like, are you going to actually go to that class tomorrow? First, if you don't expect that going to that class is going to help you learn calculus, then you're not going to go. Or if you expect that it will help you learn calculus, but you really just don't value what you're going to learn that much, then maybe you're also not going to go. So it's sort of the combination of these things, expectancy and valence, that sort of takes us along this thing of these stages of motivation. And so I mention this all just to say that motivation is really complicated. And so for me, I again use this as a self-reflective tool. When I design a course or I do things with students and I think, oh, if I do X, it's going to make them Y, then I sort of try to stop myself and say, like, actually, how do I know that? It really depends on a student's sort of motivation profile. I also find this model can be helpful in talking with students individually, right? Like if I have a student who's struggling in a class, oftentimes like there are motivation issues involved, and having this model at my fingertips has helped given me like a foothold to try to figure out what's going on with the student. I would like to say a few words about inclusive teaching and how I think about that in designing courses. And when I tell you in a moment why I think inclusive teaching is important, I want to introduce one other idea, which is the idea of belonging. And so things that a student might say when they feel a sense of belonging are things like, my teacher knows my name. Or if the student is experiencing peer acceptance and support, they might say something like, my group mate told me I did a good job and she acknowledged what I was good at. Another part of belonging could be instructor acceptance and support. Like the professor always tried to listen to the students' opinions and understand them. And I introduced this concept because I think there's pretty good evidence that having an inclusive classroom or teaching environment actually helps student learning outcomes. Before I say that, I guess I should really say that for me, the first reason to have an inclusive classroom environment is because it's the right thing to do. But secondary to that, when we think of the learning outcomes for our students, there's this evidence that says an inclusive classroom environment predicted students' belonging beliefs. Their belonging beliefs predicted their motivation and engagement, which ultimately predicted their achievement, their performance for learning outcomes in the course. So the conclusion of this study is that when a student feels included and feels a sense of belonging in the class, it sets off a chain reaction that concretely leads to better learning for them. So setting up inclusive learning environments is really important. And I'll just mention some of the ways to do that. Some ways are, thinking about your syllabus design, thinking about issues related to inclusive language, thinking about ways to mitigate your own and students' own implicit bias, thinking about stereotype threat reduction, thinking about active learning. And I'll just say that I hope we have time to discuss some of these things, because any one of these bullet points, we could spend like hours talking about the specifics of why it helps inclusion and what are specific ways to implement it. So maybe we can chat about some of those things later. Let's spend a few minutes and I can introduce you to how I'm currently thinking about my discrete math course. So here's my course description. This course will help you understand the world through a mathematical lens and will develop your powers of argumentation and critical thinking. We will explore and utilize diverse areas of discrete math, including logic, set theory, functions and relations, combinatorics, probability, networks, and more. We'll also discuss methods and styles of mathematical proofs in order to prepare you for more advanced math classes. Finally, while mathematical knowledge is often perceived as being pure, we'll highlight some ways in which it is socially constructed and hence subject to human limitations and biases. And I'll come back to some of that in a couple minutes. Here's my course format, statement of course format that's in our course catalog. It says, to afford students flexibility during the COVID pandemic, this course is taught online. Students will watch lecture materials asynchronously and will participate in a once per week synchronous small group tutorial meeting with the instructor via video chat. I'll say more about that in a few minutes as well. And finally, this is the statement of how students will be evaluated that I put in the course catalog. Students will complete checkpoint quizzes on videos and reading assignments, regularly assigned homework problems, and reflective writing assignments. To move towards a non-hierarchical, transparent, and egalitarian grading system, the instructor follows the policy of ungrading, which means that over the course of the semester, I'll ask students to develop a rubric to assess their own learning, and students will evaluate themselves according to that rubric. So, I'm not going to walk you through my whole syllabus, but I'm going to show you snippets of it. This is what it looks like. I do a visual syllabus. So some years back, I translated from my sort of wall of text-like PDF document to something that looks a bit more like this. Here's arguably one of the most important sections of that visual syllabus. And I think for the purposes of our discussion today, it might be the most important. It's what is the actual structure of the course. So what I will be having students do is do some reading assignments, which include portions of a textbook and some other materials as well. Students will also watch some brief presentations of core material in videos. And then after watching the videos, there will be some very brief multiple choice checkpoint quizzes on the main ideas that I want students to take away. Every week, there will be this synchronous small group meeting between myself and small groups of students. And then students will practice what they've done by working on problem sets to explore and solidify the ideas that were developed over here. All of this takes place in a framework of ongoing feedback from me and ongoing self-reflection by the students about their own learning.
So Chad, we have one other question.
Yeah, please.
Someone said they've only recently been exposed to the visual syllabus. Are there resources out there to help create these kinds of things for people that have don't have really good design skills?
Yeah, honestly, I have terrible design skills. And so I was very fortunate that someone helped me do this when I first did it. So in that vein, let me tell you a couple things. The first time I did it, I used a free online tool called PictoChart. And maybe I can type that in. Let's see if I'm capable of typing that into the chat. Whoops. More chat. Send to all panelists and attendees. It's called PictoChart. There we go. And it's free, and it's meant for people like me who don't really have design skills. So it's very much like a drag and drop, here's nice looking templates sort of thing. The one problem with PictoChart is that at least at the time I was developing in it, there was no way to share an editable file with other people, which of course like then prevents this sort of easy collaboration that people are talking about. So I developed in like word processing, like I use Pages on Mac. I developed a Pages document that has some of my visual syllabi in it so that I can share that with people. I'm very happy to share that with anyone who wants it, for sure.
And someone makes the note that if you're doing a visual syllabus, which also applies to any other form of syllabus, make sure you keep accessibility issues in mind, depending on who's in your class.
Absolutely. And I don't know what whoever made that comment, I don't know specifically what they had in mind, but I will say that for me, this is the other most important part of my syllabus where I talk about the course environment. So I talk about students deserve to be addressed how they want to be addressed. I talk about diversity and Title IX and academic integrity, but I also talk about accessibility because I think like it's always a work in progress. And once we say like we've achieved accessibility, we're inevitably ignoring something. And so I do my best, but I tell students always that if there are issues like, you know, to talk to the college person who is a liaison for that, or if they feel comfortable enough to please come to me directly. I do my best to follow all the accessibility guidelines, but if I slip up, I hope someone will, you know, call me out on it.
How many students are in your class, in the discrete math class?
I'm going to come to that in a bit. So Williams, we're a small liberal arts college of about 2,000 students, undergraduate only institution. So the sections I teach are around 30 students a piece, and I'll be teaching a couple sections. Like certainly what you do, the way you structure a course, of course, depends on class size. And so if people are interested in thinking about ways to scale up, we can maybe talk about that when there's Q&A time. Okay, so basically here's what my pedagogical design looks like. And, you know, I talked before about these things of being knowledge-centered, learner-centered, assessment-centered, and community-centered. And then like, here's all the things I have my students do. I have them do reading, watch videos, and take a checkpoint quiz. They're gonna attend a weekly tutorial with me. They're gonna do a problem set. There's an opportunity for asynchronous discussion, like a discussion board. There's office hours they can come to. And then there's this self-evaluation that I'll be having students do every week. And all I did was I mapped out for myself which of these centerednesses I thought each of these things was touching on. And I just look to myself and say, am I hitting all of these things, right? So again, for me, this is just sort of like a way to try to be intentional about connecting my course design to what the literature says contributes to a successful learning environment. I'm not going to go through all of these components of my course, but I'll show you a few of them. So reading, I'll be having students use this textbook. This is Discrete Math with Applications by Dept, but I'll be calling on some other resources as well. So especially for the parts of the course that are about logic and set theory, I really enjoy Eugenia Cheng's book, The Art of Logic in an Illogical World, which I think brings the ideas to the reader in a very like concrete and tangible way with examples that like matter to students. So I really like calling on material from that book. I also really like emphasizing that like a lot of places on Earth have been developing lots of mathematics for a lot of history. And so like, even though everyone loves to talk about like the Greeks, when we talk about logic, like lots of parts of logic actually developed in different places all over the world. So like, I show my students, you know, some some parts of discrete math and how they were developed in various parts of the world. I think it's really interesting to think about what does it mean to know something or to say something is proved, right? And we see this playing out in a lot of modern sort of high-end mathematics, that complicated proofs come out and who decides whether they're right. And when we have folk theorems in the literature, like who decides that those are right? And so I think there's evidence that, you know, what is known or proven is maybe not quite as objective as might appear at first glance. And so we'll do some readings around that issue. I have my own set of lecture notes that I share with the students as a resource, and so forth. Then students will of course watch videos. I will probably make some of these videos, but I'm a big believer in like not making videos that don't need to be made. So, you know, if you Google Fermat's little theorem in YouTube, if you search for it in YouTube, you're going to find whole bunches of videos, and like all of them are better than what I would make. Like Mo Omar is like a way better lecturer than I will ever be, and so I'm perfectly happy to use his video. Right. So, oh, am I not sharing? I just heard that I'm not sharing audio.
Yeah, we didn't hear you.
So sorry. Well, it's not me you didn't hear. You didn't hear, so that's fine. You're not going to hear Mo, but you can hear him. You can hear him on YouTube if you want. Just to show you another example, right? You won't be able to hear it, but maybe you can hear me. This is like a video about proof by contradiction, and it's like a really good video about proof by contradiction. Like, why would I make another video about proof by contradiction when there are so many and they're all better than what I'm going to do, right? So I may make some of my own videos, but I'm actually like perfectly happy to use good videos that are already out there. And not only do I not think that I'm special, there's nothing special about my lectures, I think that it actually like benefits like some students might do better with someone else's explanation than mine. So I think sort of having like a variety of sources for some of this lecture material can be a good thing.
So someone asked if, do you ever get pushback for using other videos, that complaints from students who say that that means you're not really teaching because you're not doing the videos yourself? Yeah. And I want to add to that, one of the issues with using videos by other people is that notation can be inconsistent, and it's something to be aware of.
Thank you for, yes. So I didn't say this, but I am very conscious of that. I will try to choose videos whose notation comports with mine, because if it doesn't, it creates a lot more cognitive overload for students. If I'm gonna purposely choose one, I mean, I will occasionally choose one, and I'll tell students like, it's a thing in math that people use different notation, but then I'll try to help them through it, right? I'm not just gonna like throw them to the wolves or whatever. I will say like, you might notice in this video, different notation is being used. Like, we tend to do it this way in our class. You'll see that the lecturer here does this instead, this sort of thing. And so, yes, like being aware of notational issues is really important. Anything that's posted on YouTube, you can use. In terms of like complaints from students, I didn't include it in this talk, but I talk with my students a lot about what learning is, okay? And so there's a slide I show my students that says like, on one side of the slide, there's a glass that has a little bit of water in it, and there's like a bottle that's pouring more water into it. And like my caption on this image is like, this is how we think learning works, right? It's like, oh, the student is this partially filled glass, and like, you know stuff, and like, the way you learn stuff is like by me telling it to you or something. And then on the right-hand side, there's a picture of like a women's soccer team at practice. And I'm like, this is how learning actually happens. So I say to my students, like, if you were a soccer team and I told you the way that you're gonna go win games is like that, I'm gonna explain to you how to play soccer well, and then you're gonna be awesome and you're gonna go win games, then like, you'd say that's ridiculous, right? And so, so that is why the thing that matters in your learning isn't what I am saying to you. It's like how much you're engaging and participating in the learning process. So I have all of those kinds of conversations with them, like a lot. So I sort of like learned the hard way that I have to prime them really, really hard for that. But I mean, all I can do is be honest about my belief. It does not matter if I say it or if someone else says it, so long as it's clear, right? And if a student's not engaged, it doesn't matter who says it. Okay, are there other questions right now?
I don't think so.
No? Okay. So that was a little bit about videos. After videos, I have my students take just some like really brief checkpoint quizzes. This gives them sort of like immediate feedback on their learning. Like, did they get some of the basic, usually pretty conceptual or basic mechanical sorts of things that I'm hoping that they'll have taken away from the reading they've done and the lecture material that they watched. It is important to me to connect with students. This is where, again, like realism comes in. It's like teaching online during COVID is just not ideal, right? So I'm letting go of the notion that it's going to be perfect. It's okay that it's not going to be perfect. I'm trying to do something somewhat reasonable that will help my students. So here's what I've decided. This course meets for 75 minutes twice a week, and I'm teaching 2 sections of it, and there's 30 students per section, and I would like to have 5 student group, I would like to have groups of a size of 5 students to meet with. And so really what I have is 300 minutes of class time per week to work with. And amongst my 60 students, if I do groups of 5, that's 12 tutorial groups. And that means I can have 25-minute tutorials. So what I plan to do is every student is going to be part of a group of 5. Every group of 5 is going to have 1 synchronous meeting with me per week, 1 25-minute meeting. And that's just going to be a time when they're required to be there and connect with me. And I'll answer whatever most pressing questions they have that haven't been answered through another venue. We'll work some examples together. We'll talk about any logistical matters. I'll ask them how life is going. All of those things. Do I wish I had more time than that? For sure. I see someone asking, are these individual, small group, or whole class? These are small group. So this is the way I'm choosing to use this time, is rather than ever meeting with the class as a whole, I'm just going to have students have small groups. I am not going to change these groups every week. I want students to be able to build a little bit of community with some of their peers, but I may switch them up once or twice over the course of the term just so they can meet a few other people. Okay, and then since this is an ungraded class, this means that I'm going to be asking students to evaluate themselves. And so every week, they're going to keep a document and they will update every week. And in this document, they're going to flesh out with increasing detail answers to these questions. Why are you actually taking this course? Like, what do you want to get out of it? What are your goals? Second question is, how are you going to do this course? Like, how much time are you going to spend on it each week? When are you going to spend that time? How are you going to react when you encounter challenges? Like all of these sorts of things, like develop an actual game plan. Then third thing is keeping in mind your goals for taking this course. Like, how are you going to evaluate yourself? How are you going to know if you're getting out of it what you want to be getting out of it? And then fourth question is apply those criteria. Like, are you doing what you said you're going to do? Are you making the progress you want to make? If not, why not? You know, that sort of thing. And so they'll do this every week and have it be an evolving document.
In the tutorials, are the groups given additional assignments in preparation for the tutorials, or are they just a time to discuss other things going on in the class?
For me, it's going to be a time to discuss other things going on in the class. I don't think I have enough time so when I would teach this class on the ground, I'm teaching it in a flipped classroom format. So students are still reading and watching videos at home, and we're using class time to do a bunch of small group interactive activities that I've designed. I'm just not doing those in this online class because it's COVID and you can't do everything.
And are you assigning the groups, or can they self-select?
I tend to assign them, and that's because there tends to be a fair amount of like racial, ethnic, and gender and other kinds of segregation that happen, and that can sometimes be like alienating for people. And so like there's a bunch of rules rules is the wrong word, that there are some principles of group design that people may be familiar with about how to get diverse groups without like having people be tokenized. And so I tend to try to do that with my group design.
So in this self-evaluation, when students are being asked to respond to why are you taking this course, how do you respond to students who give the reason, I want to fill the requirement and move on?
This is ungrading. I mean, I would try to talk to them, and they want to fill the requirement for a reason, right? So what I would do is try to pull on that. So like for a lot of students taking this course, it might be because I want to be a computer scientist, right? And that's at least true at my institution. That's why they might be taking it. So then I would say like, okay, why do you want to be a computer scientist? Okay, and then they would tell me. And then we would try to explore like, well, what in this class is actually like connects to what they want to do as a computer scientist, right? But I mean, I don't have a problem with the student telling me they just want to fulfill the requirement and move on. I just need to work with them to find the thing that is nonetheless going to motivate them to learn something. But in the end, you know, it goes back to motivation. I can't tell a student what their goals are, right? The student knows what their goals are. And so that's kind of like, I can try to help them be reflective, and I can just try to work with their goals. That's really what it comes down to for me.
Thank you. And I just want to say to the other people asking questions, I am keeping track of your questions, but given the time, I'd like to let Chad finish his presentation, and I'll return to those questions at the end.
Okay, so really, this is my last slide. If I could just sort of encapsulate some of the main things I have been thinking about for myself as I approach the fall, it's that, especially in very distressing and weird times, being human is more important than doing math for me. An online course is first and foremost a course, so I never focus on the online part of it first. I just think about course design in general and then try to translate it to an online format that's going to work. I am always inspired by the really rich and valuable learning science literature that's out there, and that also, given these hard circumstances in the world, both for instructors and students, I'm just telling myself I don't have to do all the things. It's okay. It's okay that I'm not going to do the usual in-class group activities that I do. It's okay that I'm letting some things go. My students will hopefully still learn some stuff, and we will get through what is likely going to be a hard semester.
Thank you.
Yeah, you bet.
Okay, so we have a bunch of questions. Do you have a specific resource that you can recommend about the idea of making diverse groups without tokenizing members of those groups?
Oh, I'm sure at this point I have sort of internalized these. So it's a great question to ask, like where in the literature to point for that. I'm very happy to dig that up and send references that we can post if people want that. But basically, I especially know this to be true of gender. What you want is for no one to be a gender like army of one, right? So like, because the field of mathematics has historically had tons of gender bias, like my courses tend to have more men than women in them, and I will never form groups so that a woman is the only woman in her group, just to give one example of how I approach that.
Okay, someone else apologetically asks, to be convinced that ungrading is worth the extra time that it takes to guide students' ungrading plans?
Oh, well, I would ask, what does worth it mean?
Well, I don't know if that person wants to respond to that. I guess we could rephrase the question of how much extra time does it take for you to engage in this ungrading model?
Oh, I should say, this is the first time I'll be doing it, so I don't know the answer to that question. What I will say is that for me, it will remove the time I spend thinking about points, and it will remove the time I spend discussing points with students. And so that's, I think maybe if the concern is about like time, maybe that's where the time savings comes. But I would say like, that's not why I'm doing it. I think probably, you know, this is right now we have an audience of, I don't know, 100 and however many people here. And I'm sure we all have like I'm sure among us, there's a very diverse set of views about grades and grading. For me, I've sort of reached a point where the letter grade system is not the thing that feels right to me, like me assigning a letter grade. And so that is why I'm moving to this system.
Someone asked if you'd be willing to share your syllabus.
Yeah, it's actually, it is public. So, I mean,
if you send me the link, I can link to it from your abstract on the webinar page where we post this recording.
Absolutely, I'll send that to you.
Excellent. Okay, so the same person is trying to clarify, what will students get out of ungrading in addition to or separately from what traditional grading would provide?
Oh, what I hope it does is make the class more learner-centered for them, right? Like what I want is for students to be able to really follow what's important for them. And like my role is to help them develop that, right? Like, because they don't know discrete math, and I at least know some discrete math, right? But I want them, like I want the class to be able to do the thing that they want it to do. And so what I hope is that all this reflection is a way of leading them to that.
Did you need to get institutional permission to ungrade?
I mean, technically, well, the answer is no. Maybe I'll be in trouble back at home after this webinar, who knows? Hi, other Williams people who are watching this webinar. I mean, I will still assign a grade. I'm just going to assign the grade that the student tells me to assign them.
I hope you'll report back to us on how that goes. It's very intriguing.
I will.
There are a few comments and questions about rote learning, that some people feel it's really important for students to memorize certain definitions or theorems, because if they don't have them right at their fingertips, it might be difficult to construct proofs. And that's a more difficult thing to enforce in an online setting. The feeling is that if you're in class, you can, let's say, give a quiz that you know they aren't opening a book to answer. So,
sure, I guess I would say, maybe this just goes back to a diversity of teaching philosophies. So since almost forever, all quizzes and exams that I've given are always open book, open note. And I truly believe that's because I'm asking questions where being open book is actually like not that much of a help, right? It's like having access to a reference material, but like sort of memory is not the thing that I am after. And so I guess I don't know. I mean, I think it's a very legitimate concern. Like if there's things that I want my students to do by rote, then, you know, we set up an online mechanism to do that, right? Like Maybe there's a bunch of multiple choice questions that students have to complete, or maybe there's a bunch of web work, right, that they do to like build those skills, or like whatever it is. I think there's ways to do it. It's not what I'm so much doing in this course.
Okay.
Yeah.
Thank you. So there's one person in the chat who, there's been a lot of talk about how to assign people to groups in a way that doesn't tokenize people, or that the groups are efficient, and especially with small groups that may be harder to do. And one attendee in particular, who self-identifies as Black, says that they don't really care whether they're the only Black person in their group, but they find it more strange that their race affected where they were placed. And I think some of that comes from just being sensitive to helping your students learn how to deal with those sort of interpersonal issues more than exactly who's in the group. But I don't know if you have a different reaction to that.
Well, look, I mean, here's my reaction. Like, I'm a white dude in mathematics, and so I have never been minoritized in this field. So I've never had to worry about that experience. So whoever is having that experience, like, I trust what they say. Most of the literature that I know about this focuses a bit more on gender, and I do think there's evidence that, like, being a woman in an otherwise all-male group there's some evidence that, like, it exacerbates stereotype threat, for example. And so that's the sort of thing that I am keeping in mind. But again, this is like a kind of thing where I have to keep my eyes and ears open, because, like, I'm a white dude, so yeah. Most people in math look like me, you know?
So that brings back to a question that was asked early on, and this person said if there's time at the end, they would love to hear more about implicit bias mitigation and reducing the impact of stereotype threat. And I'm intrigued by the use of your word mitigation of implicit bias, which is a much more active goal than training or talking about it.
Right. Okay, so let me say some things about that. I'm going to go to my secret slides that I had. Let's see. Okay, maybe I'll just do it this way. Can you, even though I'm not in slide presentation mode, can you all see everything okay?
Yeah.
Abby? Yeah. Okay. So, I mean, implicit bias, my working definition that I'm calling on is unconscious attribution of particular qualities to a member of a certain social group. Everyone has it. It doesn't make us necessarily bad people. We all have it. And essentially, the way it's been explained to me is that your brain is trying to shortcut. It's like a heuristic that your brain has created at some point, but sometimes our brain's heuristics are wrong. And so there's really strong evidence of how much we all have implicit bias. This is a pretty famous study published in PNAS in 2012. And what was done in this study is that, like, they, like, constructed a search for a scientific, like, lab employee, like a lab assistant or something. And they did a study where they made up a bunch of resumes, and sometimes the name on the resume was, like, the name that sounded like the student was male, and sometimes it sounded like it was a woman's name. And then they did this thing where they would give it to hiring faculty who were men and ask them to sort of, like, rate these resumes, and then give it to women. And the short story is that both male and female faculty rated the resume that had the woman's name on it, as being less competent, less hireable, less deserving of mentoring, and even offered her a lower starting salary, right, than the completely identical candidate on paper, but when there was a man's name attached to the resume. So, like, it's like a really powerful and upsetting study. And to make matters worse, there's this thing called, like, the bias blind spot. And so the idea here is that we all think biases are more prevalent in other people than in ourselves. And so there's this sentence that says, we found that none of these bias blind spots were attenuated by measures of cognitive sophistication. If anything, a larger bias blind spot was associated with higher cognitive ability. And another way of saying this is like, the more we think we know, the more we think we can think our way out of implicit bias, but we can't. Okay, so I think like having humility about this and like recognizing like it's a thing we all have is an important thing to do. And I think there's a paper I really like. This is from BMC Psychology in 2019, and it was just some ideas, some evidence-based ideas about things that can help us reduce our own implicit bias. Your implicit bias comes from whatever thing your brain did wrong, but you can change it with conditioning to some extent. So if you hold an implicit bias that, you know, people from a certain ethnic background are like less capable mathematicians, you can combat that implicit bias by actively building new associations, like people from that group, like here's all the excellent mathematicians, right? You can solicit feedback from your students when you teach or observers when you teach and see if they see things that you are doing that indicate implicit bias. There's evidence that mindfulness can help. Like if things you're doing, if you're kind of like plowing through your teaching or whatever, if there are moments where you sort of like pause and think about what you're doing and take a deep breath and be mindful, that actually can mitigate implicit bias. There's like sort of logistical things you can do. Like if you are grading work, if you have a mechanism to grade it anonymously, right? That's been shown to mitigate bias. You don't know whose paper you're grading. So those are a few ideas. I can say a couple things about stereotype threat. So stereotype threat means the feeling of risk of conforming to a stereotype. And so here's a really kind of important and powerful study from Claude Steele. So here, there were groups of Black and white students, and they were giving like a learning task, which was like, do this GRE verbal test section. And in one treatment of the experiment, everyone was told like, this test is diagnostic. Like we're doing this to figure out how smart you are, right? And then in another treatment of the experiment, all the students were told, this test is like just a thing we're doing. Like this doesn't mean anything about you. Non-diagnostic test, just a thing we're doing. And you can see the difference between the mean score in those two treatments. In the non-diagnostic treatment, basically the race gap essentially disappeared. Okay, and so that is taken as evidence of a way to combat stereotype threat. Here's another example. This was the score on a particular math test. And what do I want to say? There's a very similar thing where in one treatment of the experiment, the students were told like, men are better at math than women. Like now go, or like there's a gender difference in mathematics. Like now go take this test. And then the other treatment, they were told that there is no gender difference. And you can see the sort of like disparate outcome here when gender difference was alleged versus when it wasn't. And so there are also some documented ways to mitigate stereotype threat. You can set high standards, but communicate constantly to your students that they are all capable, like you believe in all of them. There's this really interesting thing that you can have students affirm their core values before doing assessments. And I do this in my classes. I literally, at the start of any like exam that I would give, there's always a question 0. And question 0 is like, take 2 minutes and write about what's important to you in life. And they never write like, nailing this proof by induction is important to me. They write like being a good human and like helping the world, or like my family's important to me. And there's actually evidence that that mitigates some of the effects of stereotype threat. I don't have to go through this whole list, you can read these, but there's a bunch of stuff that you can do. So I think that's what I had to say about those two topics.
So it's a little bit after 3, and I don't know if you have time to hang in there because we still have over 100 people who have hung around to this point.
I do, sure.
So what technology do you intend to use in the in those small group discussions, the synchronous discussions, so that students can share math with each other?
Yeah, look, I don't know that they're going to be able to. So I don't have my class lists yet. And I'm going to poll my students when I do have them. So here's what I'm thinking. I will be using Zoom. That's the technology that I'm going to be using. I can definitely share. It's easy for me to share my iPad. Zoom has that as like a super awesome built-in functionality that I can like say share iPad, and then from my iPad I can wirelessly just like write on it and it'll be sharing that on the screen. I will poll my students. I will see some of them may have tablets, some of them may not. Some of them may have smartphones. For the ones who have smartphones, it's perfectly possible to just write on paper and either using a document camera or your hand, right? Share that way. I may have students who have none of those things, right? And so again, just to be clear, I am not necessarily viewing these tutorial sessions as like a super intensive exchange of mathematical material. Like they might be, but it might be students asking me questions and then I'm doing the writing and they're watching, or it might be just us talking about stuff, right? So I think I'm gonna have to wait and see.
Yeah, I saw a presentation yesterday, I think, from some folks at the Dana Center, and they required students to actually physically buy a small whiteboard. And in online environments, they said it's really easy to just hold it up and show it, and it's easier to see perhaps than things written in pen on a piece of paper. They also said that for people who are teaching in face-to-face classrooms where the students are socially distanced, holding up a whiteboard for someone else to read from 6 feet away may be more effective as well.
Yeah.
It's an interesting idea.
Yeah, that is interesting.
Someone asked if you would be able to comment just on a little bit more on teaching discrete math in a flipped classroom. I don't know if there was a more specific question than that.
Okay, I mean, I can say some things. In many aspects of the course, when I was teaching it flipped on the ground, are similar to what I've described here, right? So students were watching videos and reading stuff and taking checkpoint quizzes before class time. So the difference is, what were we doing in class time? And I would say that with the 75 minutes that I was allotted during each of the twice per week class sessions, I would spend maybe like 25 or 30 minutes of that engaged in like Q&A with students. So I would sort of do like, okay, everyone remember, here's like the main points you're supposed to remember quickly from the videos. Like, what was the most complicated parts? What do you want to see more examples of? They would tell me, we would do it together. And then I would say for the last 45 or 50 minutes, I had group activities that were in place every day. And what those activities were just depended on the particular unit of the class. It could be a worksheet where they have to work with quantifiers. It could be counting problems. It could be practicing proofs by like writing them on the blackboard and having groups construct a proof and then critique another group's proof and like this sort of thing. So whatever the activity was just sort of depended on the day. And then some days I would try to leave a little time for them to start their homework in class together. So there could be time to get started on problems and work collaboratively with each other and with myself there to guide them a little bit.
And how do you address issues related to diversity in an online classroom?
I guess I would say what issues, because maybe the answer is it depends.
Yeah, maybe you can just comment on if you're aware of them. You said you haven't taught this course until the fall, but you have taught online before. Mm-hmm. What are different ways that diversity issues play out in an online classroom versus a face-to-face classroom, if there is a difference?
There's so many things to say here that I'm struggling with where to get started. Look, there's the there's the diversity piece and there's the inclusion piece, and those are both important things. I want my classroom to be diverse, because the world needs that, and the world of mathematics needs that. And if we want our field to survive and thrive, then we need all the people involved, like not just all the white dudes or all the people who, you know, grew up in upper middle class suburbs with like really highly capitalized school systems, this sort of thing. Like we need everyone, right? So having a diverse classroom is important to me. I think when I'm doing things on the ground, I often have the opportunity to talk a lot with students before they register, right? Like this is kind of like a Williams thing, like students will drop by your office, be like, tell me about your class next term, tell me about, right? So I have the opportunity to like talk to my potential audience and like tell them why I think it would be great to have them in the class and why I think they can succeed and all this sort of thing. I think that's going to be much harder this fall, right? Like I'm not going to be on campus at all physically. I'm not going to have an office that students can walk into to have those kinds of conversations. So I feel like I'm going to have a little bit less like, I don't know, a little bit less like hands-on influence over trying to get people into my course. That's like one thing. Then there's like the inclusion piece. And I mean like, there's just so much to say about that. Like for some students, so it's, I should say, it's really complicated what's going to happen at Williams, right? We will have some students on campus and some students off campus. Some classes will be taught on the ground, but with a hybrid portion that remote students can take. And some classes like mine will be taught exclusively online. So like, I think students' life circumstances and where they are physically located can create complications. And I don't know what those are going to be, but I know that I'm going to have to be aware of them, right? Like maybe there's a student who has to stay home because of their family circumstances, and that's related to some axis of identity that's important to them, but also maybe being at home is really hard and really taxing, and makes it harder for them to complete the course, right? Like these are just things that I'm gonna have to be aware of, but I think I'm not gonna know them until I like meet my students and see. It's another part of why I think this kind of intensive self-reflective piece might be valuable, because I will hopefully be hearing from students a lot about like what their experience is and what is working for them and what is not working for them. So I don't know. I mean, this feels like a totally unsatisfying answer to a really hard and really important question. I'm happy to talk about it more if people have more specific things they want to say.
Well, I think if you had all the answers to how to handle diversity and inclusion, the math world would be a very different place at the moment.
Oh, can I say one thing? Let me say one more thing though. This is a very like, I was talking like up here and this is like a much more nitty gritty thing. One of the reasons I love the YouTube videos that I pulled and that I'm using is back to accessibility issues, is they're captioned. And so like for me, like if I'm gonna make my own videos, I gotta make sure I figure out how to get them captioned. On YouTube, I have like the ability to choose videos that are captioned. So in terms of like the like neurodiverse axis of diversity, that is possibly something that's going to be like useful to have on hand.
Okay, there have been a couple of questions in the chat about dealing with accessibility issues, and unless Chad has something specific to add to that, I do want to direct you to a webinar we had 2 weeks ago that dealt with accessibility best practices when presenting math online, and you'll find a recording of that on the same page where you can find the recording of this webinar. So that may be one particular resource that may be helpful to you. And then the only other thing that I've seen sort of a consensus of questions about is about the idea of holding synchronous classes. And do you worry about different time zones or people having, you know, childcare responsibilities or all the other things that can interfere?
Absolutely. So here's what I will say. So first of all, I was on leave last year, so I was not teaching in the spring when kind of COVID hit and schools had to suddenly go online. It made very good sense to me then. So like my school made the decision to ask, not to insist, but to ask faculty to please not have synchronous components to their courses for all of those reasons that you're mentioning. For the fall, the vast majority of Williams students have indicated that they would like to come back to campus. That I think is around like 1,700 of our 2,000 students or something like that. But there will be some remote. Everyone is aware of what the course schedule is. So people will at least know that they would need to be free at a particular time. But look, that said, that's one of the beauties for me of like not doing my synchronous component as like a lecture. It's like if I'm doing these tutorials and I have a student who's in a weird time zone and they're like, you know what, I just can't come to the tutorial at the time like that this class is scheduled, then I'll find a time to meet with them. You know, it's fine.
Okay. And of course, that becomes much harder if you have 300 students in
That
the class,
becomes
but
way
as
harder.
does everything else here. So.
Yep, but I will say that this is at least my decision to run these tutorials during the scheduled class time, right? It's not like I'm scheduling these on a one-off basis with students or something. It's like at least students will know when they register that the hope is that they could be free for 25 minutes during one of those blocks. Yeah.
Thank you.
Yeah, you bet.
Well, thanks to everybody. There was some great conversation going on in the chat. We still have 90 people here 15 minutes later, so that's been wonderful. Chad, I think this was tremendously helpful, and I think we're seeing a lot of comments in the chat that I'm not the only one who thinks that. So I really appreciate you taking the time to do this for us. We will post the recording. I've put the link in the chat box. It's ams.org/education/webinars. You'll see the link there, a copy of his slides, and anything else, Chad, that you choose to share with us. I'm wondering if you have a bibliography for the references that you cited in your presentation. I mean, if not, we can find them ourselves, but if you have something.
No, you know what? I love it though. Like, why would I not have that? What if I can work on putting that together and I'll send that to you as well.
That would be just great. That would be really wonderful.
Awesome.
And then again, the link to your syllabus, which I really, really enjoyed. So
very good.
Thank you. Thanks everyone for joining us. Good luck with your plans for your fall courses. I think we all have our work cut out for us, but I think everybody's going to rise to the occasion, and it's going to be a really great semester, even though it might be a weird one.
Be well, everyone. Take care.
Yes. Good luck. Thank you.